me here. Let's try to do a sample uh, expert eval. Okay, fun function. Expression eval. So basically what I want to do is that I give some plus 5 multiply 5 2 and I should have, what should I have as my answer? I should have 10 plus 4, 14 as my answer. Yeah. Get it? What is the meaning of expression eval? It's just an evaluation expression. This is a standard example you do in every data structures course. You have given an expression and you have to evaluate that expression, and you basically use a stack or convert it to, yeah, if you have a prefix expression and if you have a stack, you can easily evaluate them. It's easier if you have postfix, but if you have prefix, what do you generally do? If you have prefix, what can you do? Hello? Forgot? No idea?
Expression tree.
If you have prefix expression tree, yeah, but how do you make the expression tree? One thing is that you can read the input from the end to the beginning. Okay, read the input from right to left and convert it to and evaluate it. That's one possibility. Yeah. Otherwise, it's more complicated. But anyway, we are not going to evaluate it using a stack. So how can we evaluate this expression? Can somebody tell me? How can we write an expression for this one? Can you try it? Hello?
Yes, sir, we'll try it.
Yeah, so please try it. Can somebody share your screen? Siddharth? Siddharth?
Sir, actually, there's some problem with my doctor racket, so maybe I won't be able to.
All right. Who can share their screen? There are Salunge, the one who posted in what? In Piazza?
Sir, I am watching lecture through mobile and not connected laptop.
Okay, you're not connected to your laptop.
Yes.
Is there anybody who is connected to laptop who can share the screen? Nobody? No. Everybody is in watch mode. Huh? Martini. Yeah, but who is in a mood to do this? Or at least tell me how to do it.
Sir, can we take the first operand and then recursively evaluate the car and the cadre?
Yeah, that's the idea. Yeah, that's the idea. So let's get on with it. So I want define expert eval. Let's shorten the name. I'm not using eval because eval might already be a function. Okay, built-in function. So let's write it e eval or a eval, arithmetic eval. A eval. So let's take an expression E. Okay. Now, what should I do? Now, I need to do a case analysis on eval. So what should be my case analysis? So I'm going to assume that what is our grammar for expressions? Grammar for expressions will be, so if I have an S, I hope you remember this writing expressions. Yeah, S goes to either a number or an operator. So let me write it this way, operator followed by, so let me call it E. So expressions are either expression E is a number or an operator followed by an expression and another operator. And operator is either plus or multiplication or division or let's say minus. Okay. And since we are writing it in prefix form, we don't need any brackets. Yeah, because if we have an expression like 3 plus 3 into 5 minus 4, in the prefix form, it will be what? Will be what?
Minus 4 into 3, 5.
Minus, then multiplication 3, 5, 4.
4.
Yeah, this will be our prefix form. So we will get an expression like this. This will be our expression. On the other hand, if you have 3 into 5 minus 4, in prefix form, it will be multiplication 3 minus 5 and 4. Yeah. So basically, we don't need to bother about parenthesizing anything because the way it will be written in our expressions, it will already be parenthesized. Okay. This. So this is our expression. This is our grammar. Now, based on the grammar, we are going to make a case analysis. Who can help me? Angit Jaiswal, can you help me here? Ankit. Hello. Anushri Dabarma. Anushri. I think everybody switched on the video and left. Aditi.
Hello.
Yeah.
Sir.
Yeah. So help me here. So what should I write so that when I get a code like this, how can I evaluate this?
Okay. Sir, should we consider like, okay, if it's just a number, then it will just return the number, maybe.
Exactly. If it is a number, it should just return the number.
Yeah.
Uh,
So we can probably use the cond special form and then
Yeah.
check if the char of the list is number.
Okay, that's okay. So let's assume that the expression is well formed. Okay, expression parses like this because, for instance, if you get an expression like this 3, 3, it's not well formed. Okay,
Yeah.
it's not well formed. So we can actually write an expression to write a function to check if a given expression is well formed. But for the moment, let's not write that. Let's assume that the expression we are given is well formed.
Okay, sir.
Okay, so in that case, what should I write? We are going to
Uh,
assume
so I have a question here. This plus multiplication minus, they can be unary operators also, no?
there can be unary operators also, but here we are treating them as binary. So this is a big problem in designing programming languages. That minus plus is not a big problem because you can always drop plus as a unary operator. But minus is a big problem in designing unary operators because minus is a big problem in Haskell also. But the reason is minus can stand for two things. Minus can stand for unary negation as well as binary subtraction. Okay, so for instance, if I have, we can have 3 minus 4 and minus 4. These are two different things. One takes only one argument, the other takes two arguments. This minus takes two arguments, and there is no one way in which you can see them as one function because this one takes two arguments, this one takes one argument. Okay, and so Haskell has a reasonable answer. I mean, they treat it as a special case. This unary negation is the only operator in Haskell, for instance, which takes one argument, and then so it is treated specially. Yeah, but in all other programming, and the reason why, yeah, I mean, yeah, that's all I would like to say about it. I mean, we can. Yeah, I mean, so what basically happens is that all other programming languages generally treat this as a separate operation. It as a special case. Yeah, so they don't see these two things as, though in mathematics these two things mean the same thing. Yeah, minus and this one means the same thing, but in programming languages they are always treated as two different entities. Okay, but in any case, in our case, we are not treating unary versions of that. We are always treating binary version. Every time it takes two arguments. All right. Now, fast, we have to finish this. What should I write?
So the base case can be that if it's just a number, then it will return a number, and the recursive call can be like we can operate the char of the list on the char of the cadder and the cadder of the list. I think cadder of the list.
Okay, so let's write it as a cond, and if it is number, then you want to return.
The number itself.
If it is a number, what do you want to return?
The number itself.
Number of e. Then you want to return what?
So the number itself.
E. Okay. If it otherwise, what do you want to do?
Sir, we have to use the operator at the char of the list
Okay.
on the like the
So let's do an EQ of char of E. So we are doing a direct implementation. Okay, this is what they call a direct implementation. And let's say plus.
Yeah.
It is a plus, then what do you want to do?
Then we have to return the plus of a eval of the char of the cadre of list.
A eval of char of the cadre of the
E.
E and
So bracket for CAD cadre.
eval of char
Cadre
of
of the cadre of.
cadre of the E. Okay. And
So the
now we
brackets for cadre.
copy this. Multiplication. Division. And here we are copying, but it is unavoidable copying, okay? Because it's a case analysis. I think somewhere we screwed up with the now it's minus. Okay, let's try to run it. At least it compiles fine. Let's write a eval of minus multiplication 3, 5, 4. IT mismatch. The expected number of arguments does not match the given number. Expected 1, given 2 arguments. Can somebody help me debug?
So the parenthesis around cadre and
Ah, thank you. Oops, that's a very costly error because now we have to spend a lot of time putting parentheses. A eval of minus multiplication 3, 5, 4. 11. Okay, we got that one correct. Is that correct? Yeah, that's correct. Let's also try this one. A eval of multiplication 3 minus 5, 4. That's 3. Is that correct? Yeah, that's also correct. So it seems like we got that one correct. All right, so now we have 30 minutes, in which case we have to find some. Everybody understood this example?
Sir, I have a small doubt.
Yeah.
So why did we take different cases for all the different operators? Because we could have simply treated the operators as a variable, no? Like char of e itself is uh, 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 it itself represents the operator.
Char of e is an operator. No, it's not an operator. It's not a function. There is no binding of that one. Okay, that star does not have any binding. All right, this plus, that's what the meaning of plus symbolic means. This plus has a binding. It's a procedure. Okay, so if I print, I think it's display. If I ask it to print this one, it will say plus. If I ask to display plus, it will say procedure. Because it does not have no. Because the point is that this plus has a binding which says that the binding of this one is it's a symbol. This one, on the other hand, the binding is a procedure. So binding means what do you understand as? Yeah, name of an object is this. These both of them are names. Okay, both of them have the same name but different bindings. The name, what does it attach to? This one attached to plus itself. This one attached to a procedure. So that's why when I ask to display plus, it says procedure. When I ask to display this plus, it says plus.
Okay, and
So similarly, there is no connection between this plus and this plus.
Yes.
I could actually put star here and it will evaluate plus as star.
Yes, sir. Okay.
Okay. So that is why I said this repetition we cannot avoid, because this repetition is where we list out the particular name and its binding. Okay. So here, this operation, we will actually see that you can write a similar procedure for interpreting scheme programs. That's what they will call. That's what they will call meta circle evaluator. Soon we will later on write an evaluator for scheme just like this. Okay, it's not very complicated. And so some people call it the most profound 5-line program or 11-line program and so on, because of of Lisp within Lisp. Okay. Okay, so let's try to understand what is going on here. I have an expression like this, and it's based on it's a list. I mean, it's a list, and I do a case analysis recursively on the list and evaluate. And this is not possible. No, it's not easily possible in any other language. I don't know if it is possible. I mean, there is no direct equivalent of this this procedure in C or any of the procedure languages, unless you decide to define your own Lisp inside your C, where you have a linked list which consists of these sequences, and then you evaluate this. And then you will be actually interpreting Lisp inside C. Okay. All right. So that's that. Is there anything else we can do? Can you think of a new question? Let's think of a new question. Why don't you think of a new question and then let's solve it and then. Hello. Think of a new question. Something which you have seen in data structures or algorithms, or something where we can represent something as a linked list, and we can go through it and evaluate it, or process it or convert it and things like that.
Sir, from the last class, we had that order and reversal left.
Yeah. Order and reversal. You want to do that now? Hello.
Sir, I couldn't come up with a solution up till now, but I would like to think on it, I think.
Oh, that one is very simple now. It's not very complicated. Somebody posted it in Piazza, the answer. But I mean, of course, you should try it yourself. It's a general technique of iteration of reversing things, because generally not just reversing things, there are, it could be done on trees and things like that. It's a general technique which is done to speed up your programs, because ultimately whenever you write a program, you want to write things in linear time, because quadratic time everything becomes very hard. Yeah, because even if, when you have 100,000 elements, it becomes like 100,000 is 10 power 5. So if you have 10 power 5 elements in your domain, a quadratic algorithm will take time 10 power 10, which is a drag. Yeah. So if you're talking about arrays and linked lists and things like that, linear time is what ideally you should aim for. Beyond linear time, things becomes very hazy. It just becomes you won't be able to. I mean, like for instance, matrix multiplication. That's one of the big problems in machine learning. When they have a matrix and they have to do a lot of operations on matrix. Thankfully, you can solve linear equations. Uh, using just by looking at each entry once or twice of the matrix. But we are not so lucky when it comes to multiplying matrices, or it's not that easy. So, and that's one of the big problems which they try to solve in machine learning, how to do matrix operations fast, and they have their own techniques, like they convert into approximate matrices, and they convert into singular value decomposition and so on. Okay. Yeah. So those who want to do the reverse, please do that. But others, please think about a problem which we can solve now using this idea, using this symbolic expression idea.
Sir, I have a doubt here in this A eval.
Yeah.
Yes, sir. In this A eval, in the definition, we have used care of cadre of E, right?
Yeah.
Yes. Is that because that the cadre of E is empty set, empty list?
Cadre of E is empty list. No. So when.
Sir, actually, when an expression like +4, then and another within that another expression. Sir, in this case that you have given, sir, in the example that you have given, minus into 3, 5, 4, right, in the right hand side.
Yeah.
Yes, sir. So actually 4 is the cadre of cadre, right?
4 is the cadre of cadre. Yes.
Cadre of cadre. So why did we use care of cadre of cadre?
Oh, no. 4 is not.
It's actually
Minus times 3 into 5, 4. Char will be minus. Char will be minus. Cadre will be this list. Star 3, 5, and 4.
Yes, sir.
And when I take the char of cadre, I'll get times into 3, 5. That will be my char of my cadre.
Yes, sir.
And char of that list will be the list 4.
List 4.
Yeah.
Okay,
now
sir.
when I take char of cadre, I'll get 4, and the cadre of that list will be empty list.
Okay, sir. That's okay. That's what about. Okay, sir. Clear. It's clear.
Yeah. So think of a problem. What can you do? So one question which we have pending is, given an expression, how do you check if it is well formed? That is one question. Think of another question. If we have nothing better, we will do that one. So
anything related to tree data structure, like
what do you, so the problem is that right now the trees, when if you want to encode it as a linked list, it's not very beautiful, because because we'll have to use them as list. Yeah.
Okay.
Yeah, that is possible. But I mean, right now, give me something which is related to. Yeah, I mean, can you think of a question based on trees?
So what about parentheses checking? So you have to check if they're all close, they all correctly matched.
Okay. How do we check parentheses? Is it possible to check parentheses? Is it possible to check parentheses? So the one problem is that when we use this parenthesis is a special case. Yeah, you have to think that this parenthesis is not part of the language. Not part of the input. Is part of language. Yeah, whenever I say quote, uh, this one actually this parenthesis is interpreted as a token separating the elements. Okay, so we'll have to use some ABC and things like that for parenthesis.
So could you
So
repeat?
can we use curly bracket?
Yes, we could use curly bracket.
So actually the curly brackets also are evaluating to the braces itself.
Or is it?
Yes, sir.
Yeah, so then you'll have to use some ABC, etc. So how do we check? I mean, if you are given this expression, how do we check if it is well formed? How do we check if it is well formed? So for instance, I give an expression. How do I check that it is well formed?
So it should be like if the expression has parenthesis, opening parenthesis, then it should have the matching closing parenthesis.
Yeah.
And for this prefix expression, the operator should come before any of the operands.
The operator should come before any of the operands. That is still not enough. Yeah, but you have to check that star has exactly 2 arguments and so on. Isn't it?
Yes, sir.
That is also there. So how do we parse? So first of all, let's try to build another symbolic expression. Okay. So if we are given a symbolic expression like this, okay, can we build so my first question is that let's imagine I am given like this. Okay, can I write a function which is like op number okay, such a thing is called parse tree. Okay?
It's 11
It's called a
o'clock.
parse. How do we build such a grammar?
Sir, so what's the exact question?
So I'm given my program takes this as an input minus star 3 4 5, and what it does, it returns me this expression op number. Okay. So basically what it does is that it replaces each token by the corresponding grammar element.
Okay, sir.
Okay. How do I do that? What should I change?
Sir, we can define that in similar grammar as you described there. Uh,
Yeah.
Either an expression gives an operator expression or it gives a number.
All right. No. See, I take this expression and I get this one in return.
Yeah, in place of in the same function, you can actually replace this where you have checked if it is a number of
Yeah.
you can replace that result e by a number.
Result E by what?
Number.
Okay, number. Just a number or
Quote number or just quote number.
so instead of quote, I'm just writing quote number. Okay.
Yeah, and for similarly for this plus, when you are checking if your carry is a plus, then
Yeah.
instead of in the result, instead of that plus, you can use quote op.
Yeah. So here I'm just using. So here, what should I do?
Quote op.
Quote up
And yeah, similarly for the rest star and all.
so you mean like this? List of quote up. Yeah.
Yeah, yes, yeah. True.
Here I can actually do a little better, but I'm just being. So now if I have a eval of multiply 3 minus 5 4, I have op number. Yeah. Everybody understood how I got that? Hello?
Sir, I didn't get that.
So basically what I'm doing is that this is another way of symbolic evaluation. Okay. So in the previous example, what I did was that I had a symbolic expression and I was assigning a meaning to each element of the symbolic expression and reducing the expression. Okay. That's what is happening when I was evaluating an expression. Now what I'm going to do is that I'm going to do a different flavor of evaluation. Now, what is my new evaluation? My new evaluation is that for each element of my symbolic expression, I am assigning an expression and I am using the same means of combination of the symbolic expression to build a equivalent expression with my new meaning. Okay, so now when I am getting an expression, if it is a number, I say it is a number, I return a number as a symbol. I was taking a concrete number and I am returning a symbol. And if it is a plus, I am saying, okay, what I'm going to do is that if it is an expression which starts with plus, then I will evaluate I will take a operator, I'll take a symbol called OP and attach with the evaluation of the first argument and second argument, which is hello. Hello.
Yes, sir.
Sir, your voice was breaking. I couldn't hear where you were saying that you would take operator co-top and then apply it to the other two elements in the list.
Yeah. So how long did you understand what I was saying?
Sir, I got the part that now what you are doing is you are taking symbol, like treating everything as a symbol now.
Yeah. So basically, this is another form of evaluation. You agree with that? This is another form of evaluation. Earlier, I was evaluating and I was shrinking my size of my evaluation. At the end, I'll have one number. Now also, I'll get an expression, but now that expression is like a translated form. Yeah. Hello.
Yes, sir.
Okay.
So from
Now
where
let
are
me
we
ask you a
getting this
question.
co-top?
Quad top. This one just returns.
Yes, sir. What is that?
This one just returns a symbol OP, and the list of these three things will give you a list of these three things. Get it?
So, but from where are we getting that OP?
That OP is just a symbol. When I say quote OP, it's just an OP. Hello?
Oh, okay. Got it, sir.
Okay, now let me ask you a question. It's more complicated. Okay. You know what is a context-free grammar? Hello?
Yes,
What is a
sir.
context-free grammar? For instance, this is a context-free grammar. S goes to AB or ABASB. This is a context-free grammar. What does it mean? It means that you start with S. Now, when do you say that what are the elements S produces? It produces, so everything with a capital letter is a variable, okay, which you have to substitute by its right hand side protection rule. So I can start with S, then I can replace by ASB. So S becomes ASB. And now I can even replace that ASB by ASB. So it becomes ASB, BB. It becomes, I can replace that S by AB, for instance. So now I'll get AA, BBB. Okay, so therefore, S produces the symbol, S produces the letters AA, BBB. Okay, this is the meaning behind context-free grammars. This is how you build context-free grammars. Can you give me a context-free grammar which will produce A power n, B power, all matching parentheses? Let's say opening parenthesis is A, closing parenthesis is B. Okay, how do I produce all matching parentheses? What is the grammar for that?
S goes to SS.
S goes to SS
Or
or
ASB
ASB
or AB.
or AB. That's already taken care of. Let's call it epsilon.
Epsilon, yeah.
Okay. This is what is all matching parentheses. Let's just quickly check. For instance, if I want to generate AA, BB, AB, this is a matching parenthesis. How can I generate this?
S goes to SS, and
SS and
the first S goes to ASB,
ASBS,
and then again ABB,
AAS,
BB. No,
BS,
okay.
and
First S goes to epsilon,
AABBS, which goes to A, B, B.
ASB. Yeah.
Oh, yeah, ASB and ASB and AA, BB. Okay. Now the thing is that most programming languages have context-free grammars. So, in fact, they have very restricted form of context-free grammars called LL1, LRK, and so on. And the first step of translating any language, this is what we are actually currently doing. Okay, we are writing interpreters at the moment. We are writing interpreters for symbolic expressions. We are assigning meaning to symbolic expressions and writing symbolic and writing interpreters for those symbolic expressions. That's what at the moment we are doing with the quote and things like that. So if I want to, but the question of parsing a symbolic expression, I give you a grammar like S goes to SS, ASB, and epsilon. And you have to write a program which will take a string like AA, BB, SAB and produce me and tell me if it parses. Yeah, if S can generate that A, BB, AB. How do I do that?
So that's the CYK algorithm.
Yeah, that is a CYK algorithm, but the CYK algorithm is not easy to implement in Lisp now. It is a dynamic programming algorithm, and yeah, it's the same idea. It's the same idea. How can we do it in Lisp? The same idea. The heart of CYK algorithm is that for every bunch of tokens, you will generate all possible non-terminals that can generate those symbols. Yeah. So here, what will you do? For instance, if you have AA, BB, SAB, you will start with this AB can be generated by S. Okay, and this again, this ABB can be generated by NS. This AB can be generated by NS. So therefore, this whole thing can be generated by SS, and therefore this whole thing can be generated by S. That's what CYK algorithm will do. So dynamic programming algorithm. Okay, so my simple question is that if I give you this this grammar, if I give you this grammar, which is E goes to number or operator EE, and I give you an expression, how do you check that that number, that given expression can be generated by E? Hello? Okay, anyway, now time is up. So for tomorrow's class, no, not tomorrow, Wednesday, you do lecture 10, tag data. Okay, and this week we will have our quiz, next quiz. Okay, it will be around fixed time, so like 15 minutes or so, or 20 minutes, and whatever has been done in so far in 10 lectures. Okay, and how many of you are actually trying, not just using the slides, but actually trying out in your racket? Hello, Pulaksh. It's like talking to a black hole, everybody. Hello?
Yes, sir.
Knock, knock.
Yes, sir.
Who was it? That was Siddharth. Siddharth always responds. I'm asking about those other 32. You know, yeah, now it's already 28. Uh, yeah, but I need some response from your side.
So they're responding in the chat box, I think. Yeah.
Okay, they are responding in the chat box. Huh? Okay, chat 6. Sir, I can't talk right now. Too much noise here. Okay, that was Angad Jaiswal. Sir, what is the difference between quote and quote? They are the same. Okay, it's just that instead of writing quote, you just put a symbol. Yes, sir. Mic not working. Okay, all right. Yeah, so you have to try out these things. I mean, you still find it all right. I think quote was this, like last lecture was an easy lecture, not very complicated. I hope you understood most of it. Anyway, let's see lecture 10 and meet on Wednesday. All right, so come prepared, do all these things. And anyway, later on the week, we'll have a quiz. Okay.
Sir.
Yeah.
Sir, in the last lecture, you explained the cons and that in your Dr. Racket file. Can you upload that on Piazza?
I actually uploaded that on Piazza, no, but except that the Piazza screws up the formatting of the file, so it becomes slightly difficult to read. But I have actually uploaded. If you see here, last week, where was it? No, only helper function we did in class. No, anything else we did in class last week? The rest you are doing.
So you had explained the cons function, how you. So you
Yes,
had
sir.
written
That.
something in your slide.
Cons. All right. In the next class, I'll do it once more. Yeah, because I don't have. I cleaned this one. This one I'll upload now.
Concat also you had done in large list.
Concatenate, yeah, but I didn't do it in my machine. You guys did it in your machine.
Yes, sir. So change it to rich text editor before posting.
Oops. Rich text editor.
So it will preserve the stylings.
Okay, I didn't know this. Is it? No, it doesn't.
No, sir, paste it again because you already saved it before without the rich text.
Control C. Yes, thank you. I was looking for this. All right. Okay. So I'll do the cons thing once more in the next class. But I think how is your, how are your other courses going on? Hello?
Sir, they're going on fine only. As in what context, sir?
Like, because I don't see, are you guys putting effort in this course? I see handful of you are putting some effort, but I think others are taking it lying down. Yeah. Yeah, because I really need cooperation from your side, because otherwise you have to watch the videos and you have to do the code by yourself. Okay, otherwise we won't be able to. All right, anyway, let's meet on Wednesday and we'll do the quiz later this week. Thank you.
Okay, sir. Thank you, sir.
Yeah, bye.
Thank you, sir.